Yeah, Bismillahirrahmanirrahim. We start our lecture today. We are looking into mapping or functions. Okay, and then the definition of the function is a mapping. You can define as f function. Set x implies y is a relationship from the element of set x to element to another set y lah. Okay, and then x is called domain and y is called codomain of function f. Okay, we have f function, and then we have x, y lah. Okay, whereby the x and y, okay, is not empty set. It's not empty set. Okay, and then later we see domain and codomain. X is we call it as a domain, and y we call it as codomain. Okay, basically it's a relationship, or we can call it mapping the relationship between domain and codomain. Okay, and then this one is just for the recap. Recap that we learned last chapter, last week. We have ordered a collection of object whereby it is defined for the set. And then we can define the element or the member as an object in the set. And then we can represent the notation by using a bracket. Okay, and then for the cardinality, the size of the set is the number of distinct element in the set that can be represented by the bar. Okay, and then the power of set. Okay, sometimes we are referring to 2e. Okay, power, the set of subset of a set. And then we have a Cartesian product of two sets, A and B, whereby A multiplied by set B is equal to AB, and A is a member of set A, and B the member of the element of set B lah. Okay, so far ada soalan ke setakat ni? Okay, this one also the recap. We have union for the logic. We are referring to the or, and then we have union. We have intersection. We represent by n. Okay, for the different, whereby the set A minus set B, whereby the x is the element of set A and x is not the member or element of set B lah. Okay, and then we have complement or negation. Okay, and then universe of discourse U minus set A. For example, we have a universe of discourse for this one. We have set A. The complement of set A is the other than set A. Okay, other than set A. And then identities similar to those from the logic. This one, okay, we map same into logic. Logic equivalences. And then we also imply the De Morgan's law. Okay. A union B is equal to complement A, set A, uh, intersection by complement by set B. And then we have intersection A, intersection by B, complement is equal to complement set A, union by set B. Okay, for the definition, let set A and B be the set lah. A and B be the set lah. And then a function, basically we define by f from A to B is an assignment of exactly one element, okay, of B to each element of A. We mapping. Normally when we map reversible. Okay. For example, if we map uh, okay, set A from B, okay, we have x. Okay, example we have fx. Okay, when we map one element of B to each element of A. Okay, this one B, this one A. We map like this, and then the association later we see either the association will be injective or bijective or correspondence, one-to-one correspondence. Later we see that one in the slide, next slide. And then as you can see also, we can write fa is equal to b if b is a unique element of b assigned by the function f to the element of a. And then if the f is the function from a to b, we can write a to b lah. A implies b lah. Okay, we have many type of functions. Okay, for example, like I said, we have many to one function, on-to function. We have constant function, we have identity function, we have quadratic function, and then we have polynomial functions. Okay, for example, okay, we have y. Okay, we have y equal to, sorry, we have y equal to x plus 3, and then we have y equivalent to x power 2 plus 1. Okay, we have said that this one are the function because every x value produce a different y values. Okay, relationship is any set of order pair numbers. Okay, okay. Later we draw okay like this, x plus 3, okay, y, okay, and then 0, 6. Okay, we map later on. Okay, for the set, for the functions. And then for the next definition, this one I explained. We have a domain and codomain for the set. Okay, okay. As you can see, if function a is equal to b, we can say that b is the image of a. Okay, or sometimes we call it as a reimage. Okay. And then the domain is the set of input numbers that we apply to codomain, and the codomain is the set of possible output numbers. Okay, we have input and output. Codomain is the output, and then the range of the f function is the set of all images of element of A lah. Okay, how do you find for the domain and codomain of the functions lah. Okay, basically, if you have a function, example, we have f implies b. Okay, for example, you have f. Okay, we add another. Okay, we add another slide. Okay, let's say you have a function f a b. Fine. Okay, we have a. So a is equal to 0, 1, 2, 3. Then we have b equal to 1, 2, 3, 4, 5. Okay, we have y equal to x. Then we have for all member of A. Okay, and then we have f 0, 1, 1, 2, 2, 3, and 3, 4. Okay, here 0, 1, 1, 2, 2, 3, and 3, 4. And then for domain, that is domain for codomain. Okay, we have domain range and then codomain. First, we will find the domain that is domain of f. We have domain. Okay, function. Okay, basically the okay domain f. Domain f. Okay, we can say this one is domain f. Domain f is equal to 0, 1, 2, 3. Okay, this one 0, 1, 2, 3. Okay, and then the range is the basically the second element of the ordered pairs in the function of range. And then the range is equal to, okay, we have range, okay, equal to range f is equal to 1, 2, 3, 4. Okay, we have domain is f that represented like this. Then domain is basically the first element of the function. So the first element b 0, 1, 2, 3. So this is the b, and then we have the range. Range is basically the second element of the ordered pairs in function. The range of f is equal to 1, 2, 3, and 4. Now codomain, here we will differentiate the range, and co- codomain is basically all the element of set B. So the codomain will be 1, 2, 3, 4, 5. Okay, this one is codomain. Okay, we have a codomain. Codomain is codomain F is equal to 1, 2, 3, 4, 5. And then check the element of range of codomain. There is one element is codomain as compared to each element. Range is subset of code. Okay, the codomain is differentiate from each other. So hope the concept of domain and range and codomain will be cleared by this example. Okay, we have range, and then we have codomain. Okay, and then you can see from here is range is a power set of codomain. Okay. Is it? Do you have any question, Fatin? Boleh ke? We have domain and we have range. We have codomain. Faham eh? Liana? Liana boleh? Hmm. Sebab 5 tu. Letak codomain tu apa-apa saja yang kita mapkan kepada A. Apa-apa saja yang kita mapkan kepada A, kita namakan dia sebagai codomain lah. B. Okay. Jadi kita tengok kat sini y is equal to x. Y also is a member of P. Okay. And then we have f function 0, 1, 2, 3, and then we have range 1, 2, 3, 4. Okay. And then for the codomain is all the element that we map. Uh, insert in the set of B lah. Yang ni adalah codomain lah. Okay. Because range is a superset uh, is a superset of codomain. Boleh eh? Okay, and then Okay, then let's see you have fx. Fx is equal to 4 lah. And then if we map 2 to 4, the image of 2 under the function of f lah. Okay, and then since f2 is equal to 4 implies that x equal to 2 or x is negative 2 lah. X we have equal to 2 and x is equal to negative 2 lah. And then pre-images of 4 are 2 and negative 2, and set of pre-images of 4 is 2 and negative 2 lah. This one is the range. Okay, basically when you talk about the range is you can map from domain A to domain B lah. Okay. Okay, this one is another example range is be more clear lah. Codomain is you map the for the domain when you map to the domain is we call it as codomain in range we can see here range is until a b c d okay, because it map from domain to codomain okay, and then suppose that each student in the class is assigned a letter grade from a b c d and f without the e let G be the function that assign a grade to students. Okay, and then we have a domain here. Okay, Chavez, Stokes, this, Dozier, and Holland. And then we have codomain and range. Okay, range we have A, B, C, D lah, that we map to the domain. Lah. Okay, and then this one is for the range. For the range, we can see only this one. Okay, codomain is all. Okay, A, B, C, D, E, F is the codomain. But for the range is only when you map for the domain. Same goes to here. Okay, we have A and B. We have A and B, and codomain is 1, 2, 3, 4, 5. All the elements in the set. And then when you see the range is when you map A to B. Domain and codomain and then you can find for the range only 1 2 3 4 lah. Okay, okay, is it okay? Same goes to here lah. We have a domain and codomain and then for the range we only have a b c until d lah. Okay, this one is important because you need to understand a little bit about the domain and codomain and also for the range. And then this one is another example. We have considered f function is domain is the integers. You map to codomain is also the integers. Okay. Other than that, you can also uh, map to natural numbers, positive integers, negative integers, and then rational numbers. How can you write this function? Fx is equal to x power of 2. Okay, what is the domain of f? Absolutely integers. What is codomain of the f? Also integers because we map z into z. And then what is the range of the f? It's non-negative integers because you map fx. For example, you have okay, you have x and then you have fx here. Okay, let's say you want 0 power of 2 okay is equal to 0 and then we have 1 okay 1 x power of 2 is equal to 1 and then 2 power of 2 is 4, 3 power of 2 is 9, and so on. It's non-negative integers until infinity. Okay, like this. Okay, we mapping the range. We mapping the range. Okay, because the range is a subset or we can call it as a power set of codomain. Okay, from negative 2 also. Okay, if you have the range 0, 1, 2, 4, 9, 16, 25, you can map negative 2 equal to 4, negative 1 equal to 1, 0 to 0, 1 to 1, 2 to 4, 3 to 9. Okay. Okay, this one is the range. We mapping the range because 2 and 3 is missing here. 5 and to 8 is missing. Okay. Okay, this one is the relationship based on the domain and codomain. Okay, I think we should take a rest.